Hey guys, welcome to Section 1, Chapter 6 of the Algebra 1 program. And in this section, we're going to talk about something very classic algebra. It's called a rate of change or slope. Okay, we've done this a little bit in the past where we calculated the unit rate of something, and it was like that number over 1, and we called this the unit rate. And this is going to be a little bit similar. So when we talk about rate of change and slope, we're actually going to be talking about the coordinate plane. And we've dealt with that a little bit as well. In the past, we've talked about simply plotting points, which we're going to need to know how to do for sure, but also this idea of positive or negative correlation. So this is considered a positive correlation, and this is considered a negative correlation. And what that means is, in the first case, as we move up in our unit, that the correlation goes up. So it's a positive relationship. And similarly, as time moves on or as units decrease, that relationship becomes a negative in a negative correlation. So we've seen that a little bit, and now we're going to put this all together for some basic linear functions. So for your homework tonight, you're going to be asked to find the rate of change or slope. And for our purposes right now, we're going to use those terms interchangeably, given either a graph or given a set of points. So let's say we have the point 2, 5, and 4, 8. And we want to find what the rate of change is, or the slope is. So we're going to use the formula, the change of y over the change of x. That's probably a brand new notation you haven't seen before. I'm using it only to get you exposure to this, which you'll see again in future math years. But that triangle symbol is called the delta symbol, and it means change of. That's what it means. But for your purposes, what that translates to is that we're going to take y2 minus y1, and we're going to divide that by x2 over x1. And remember that those stood for the first point and then the second point, because remember, it's always in x comma y form. So for your first point, x1 would be 2 and y1 would be 5. And then in your second point, 4 would be your x2 and 8 would be your y2. Okay, so then you just have to grab the appropriate numbers and place them. So y2 is 8, y1 is 5, x2 is 4, x1 is 2, and then we're just subtracting them. And that's your slope. So it's really not hard. It's a lot of verbiage and it's a lot of new kind of symbolism, but the actual math portion is pretty easy. And we want to leave it in a nice fraction, even if it's an improper fraction. And you're going to see how that translates here soon. So let's go ahead. Let's do another one. Let's say we have 1, 6 and 7, 3. And we want the change of y over the change of x. So we need y2 minus y1 all over x2 minus x1. And if you need to label these every time right now, that's totally fine. You go ahead and do that to make sure that you grab the right numbers. But once you do that, hopefully you'll get 3 minus 6 all over 7 minus 1. And that's going to give you a negative 3 over 6. And we want to reduce it, but make sure you leave that negative. We do have a negative there. So that would mean that this slope is running with a negative correlation there, as opposed to a positive. Okay, let's do one more. Let's do one more here. What if I have the point negative 2, 4, and 3, 9? All right, same thing. We're going to do y2 minus y1 all over x2 minus x1. All right, change of y, I guess, over change of x. I'll go ahead and just write the whole thing out for you again. All right, so you should get 9 minus 4 all over 3 minus, be careful here, a minus 2. Remember that the formula has minus in it, top and bottom, so you make sure that you put your negative number in parentheses there to make sure that you make the sign change as you should, because then that becomes 3 plus 2, which is a positive 5. And 5 divided by 5 is 1. Okay, so that's it when you're given points. It's just going to be identifying the appropriate numbers and placing them in correctly. So hopefully that's not too bad. And then the other problem type that you're going to see is you're going to be given a graph. And you're going to be asked to find the slope. And there's going to be 2 ways that we can do this. Okay, the one would be to identify 2 solid points. So where it crosses either the axes directly or on your grid, you want to make sure that you pick a point that's not crossing in the middle of a square on your grid. Okay, and the axes tend to be the easiest, so I kind of grab those a lot of times. And if you can identify what the point is, let's say this is like -2, 0, and this is 0, 3. I'm just making this up. Then you can use what we just did. You could do delta y divided by delta x, right? You could do 0 minus 3, and then -2 minus 0, which should be -3 minus 2, which would be 3/2. Another way that you can calculate slope when you're looking at a graph is something called rise over run. And that means that we can actually just count up and over from one point to the next. So for example, I could start at this bottom point and count up 1, 2, 3 spaces. And then we could run over 1, 2. So my run is 2 spaces. So counting from one point to the next, I could use something called a rise over run. Now the piece here that seems to trip students up is the difference between the positive and the negative. So if we run right, this is a positive slope. And if we run to the left, that's a negative slope. And let me show an example. So this one that we just did was positive because we ran to the right. But I could have an example where my function looks like it's a negative correlation and it's running left. So, okay, let's just say that these 2 points happen to be, again, 0, 2 looks like it, and maybe let's make this 5, 0. Again, you could do your change of y over change of x if you wanted. We can write that out. And we'd have 0 minus 2, and then 5 minus 0. So we would get a -2 over 5. Or if we counted the lines, we would go 1, 2 up here, right? So my rise slope equals rise over run. My rise is 2, but now I'm running to the left. 1, 2, 3, 4, 5, which is going to make this negative. Now typically we are going to want to put that negative out front and not just leave it in the bottom. If you are just counting spaces for your rise over run, it probably wouldn't be counted wrong if you just left it in the bottom. All right, so when you are dealing with graphs, you have 2 options. You can either pick your points and continue using the change of y over the change of x, or you could practice using the rise over run and just counting from one point to the next. Just make sure that if you run to the right, it's positive, and if you run to the left, that it's negative. There's 2 other quick things I want to talk about. And that is when you have a 0 slope and an undefined slope. So if you have a horizontal line, this slope is always 0. Okay, if it goes straight across, it means that there's no change. And so the slope is 0. All right, so keep that in mind if you see like a horizontal line. And then the other that sometimes trips people out, in this case, our slope is undefined. So if you have a vertical slope, or a vertical function, I mean, your slope is undefined. And what this translates to algebraically is that you get 0 in the bottom of the fraction when using delta y over delta x. Okay, so if you get 0 in the bottom, you're going to get what we call an undefined function. So in our work with fractions in the past, we never wanted 0 in the denominator, and the same is true now. Just remember, if you have a horizontal line, then your slope is 0, and if you have a vertical line, then your slope is going to be undefined. I want you to finish up your notes. I want you to read through the lesson and then begin your assignment.